In this lecture, we're going to learn about the stdq container adapter. This is a container that is going to take things in from one end and things are going to come out from another end. And this is going to work in this way. For example, we can put in data. And if we happen to need to get data out, data is going to come out from the bottom, as you see here. To support the queue interface, we need a bunch of methods. For example, we need the back method, a front method, a pushback method, and a pop front method. And we have a few underlying containers we can use to support this. But std vector is not a candidate because it doesn't have a pop front method. That's why it is rolled out here. But lest and dic are good candidates, and we're going to see that we can use them to set up a queue interface in our C++ programs. Now, here are a few things you need to know about the queue container adapter. The first thing to get in is going to be the first thing to get out, and we need these methods to support its interface. And std vector is not going to be a candidate because it has no pop front method. This is what I just said. Here is a simple function we can use to print out a queue. So it is going to be reusing the same solution we saw in the last lecture to take into account that we can use different underlying sequence containers to set up our container adapters. So the default is going to be dic also, as we have seen before. So if we print a queue, we're going to also use the same mechanism as we saw in the last lecture. We're going to be looping through our queue, getting the front element, printing it out, and then popping it off from our queue. And then by the time we are done, this queue is going to become empty and the loop is going to end, and we will have printed out all the elements. Notice that what we are doing here is not going to disturb the original queue container because we are passing this by a value. So what we have inside the function here is a copy, and you need to be aware of this. We're going to follow the same logic to clear things, but we're not going to pass by value. We will pass by reference here because we want the changes we do from the body of this function to affect the original queue that we passed here as an argument. We're going to loop around, taking things out of the queue using the pop method until our queue becomes empty. And if it becomes empty, the loop is going to end and our function here is going to return. Let's look at a few examples of how we can work with queues in our C++ program. This is how you can create it. It is going to be empty by the moment you create it. You can print it out to see that it is empty, but you can put in data. And if you print data, you're going to see that the first thing to go in is going to be the first thing to come out. This is how the queue interface works. We can add other pieces of data, and if we print again, we're going to see that the first thing to go in is going to be the first thing to come out. We can also use the front and back methods to query the data and get copies of the data we have in our queue. This is something you can do if it makes sense for your kind of problem you are trying to solve in C++. It is possible to go through the front and back method and modify the underlying data, and that's possible because these methods return references. We can use the pop method to take things out of a queue, and this is going to take out whatever element is ready to be taken out from the queue. And we can set up our own clear function to clear a queue, and it is exactly what we have seen at the start of this lecture here. So we can use that right here to clear our queue, and after we clear it, we can print it out and see that it is going to become empty. We're not going to see anything inside. We can store in user-defined types. Here is a queue storing box, and you're going to see that the first thing to go in is going to be the first thing to come out when we print it out, and this is really important to see. And we can specify our underlying containers. List and dic are candidates that we can pass here, and if we print them out, you're going to see that this is going to work. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is queue. We're going to grab our template files and put them in place like we always do, so let's do that. We can open this up in Visual Studio Code by dragging and dropping here. We will have our main CPP file, so we can clean it up a little bit, remove what we don't need here. We are going to include our headers, queue, list, and dic because we're going to be able to use list and dic as our underlying sequence containers in a minute. And we will put in initial things that we can use in this program here. So we will put in our book class. This is nothing new now. And we have our function to print our queue and another function to clear our queue. And this is something you already know from the last lecture. Changing this thing to support the underlying sequence container. This is going to work really well. We are going to play with queues first. So let's put in the code. We're going to create an empty queue here, which is going to be storing n integers as you see on this line. And then we're going to print this out. We're going to put in data, and you're going to see that the first thing to go n is going to be the first thing to come out when we print our queue. You can add more data, and you're going to see that the last thing to go n is going to be the last thing to go out. I want you to see and understand this, because this is a defining feature for the stdq container adapter. Let's pass this through our compiler. We can use GCC for the job. The build is good as you see here, so we can clear. Let's not clear. We're going to bring up a terminal window first. So now that we have this, we can clear and run Rooster. We're going to see that the first thing to go in is 10, and it is the first thing to come out when we print data. And this is really cool. This is how a queue is supposed to work. So if we add in 40 and 50, you're going to see that 50 is going to come out last because it is the last thing to go in. I want you to understand this. We can use the front and back methods to access data from our queue. So let's do that. The front method is going to give us the first element that is ready to be taken out next time we want to call the top function. And the back method is going to give us the last element in our queue. Let's pass this through our compiler. It's seen this. The build is good, so we can clear and run Rooster. We're going to see that the front element is 10, which is this guy here. And the last element is at the back. It is the 50 here. This is what I want you to see. It is possible to go through these front and back methods and modify the underlying data. So I am going to show you that here. We're going to modify the front element to 500, and we're going to modify the back element to 600. And this is possible because these methods return references, so we can go through these references to modify the underlying data. Let's pass this through our compiler. We're going to use GCC for the job again. The build is good, so let's clear and run Rooster. We will see that after we modify our data, the front element is going to become 500 and the back element is going to become 600. We use the pop method to take elements out of our queue. Let's set up an example to show you that. We are going to print our queue. We're going to pop an element, print it again, and pop an element and print it again. Let's pass this through our compiler. I don't think there is more to explain here. The build is good, so let's clear and run Rooster. And we're going to print our queue. We're going to pop an element, and the front element is going to go. This is how a queue works. The first thing to go in is the first thing to go out. So the 10, or the element in front, which is this 500 here, was the first thing to go in. So it will be the first thing to go out when we call the pop method. And this is what we see here. Once we pop again, the 20 is going to go, and we're going to be left with this data here. This is something you need to understand. We can also make use of our clear queue function that we set up on top. If you forgot about this, let's go on top and show you this again. We have that right here. It is going to keep looping through our queue, popping off elements until our queue becomes empty. And if it becomes empty, the test here is going to fail and the loop is going to end, and we will return out of this function here. Let's go down and see our example. We're going to print our queue. Before we clear, we're going to clear, and then we're going to print the queue again after we clear, and we're going to be printing the size to see that our size becomes 0 after we remove everything from our queue here. Let's pass this through the compiler. The build is going to be good, so we can clear and run Rooster. We're going to see that after we clear, the size is going to become 0, and if we print our queue, it is going to be empty as you see here. You can set up a queue of user-defined types. Let's set up an example to show you that. We can set up books here as a queue of book types. As we put in data, the first thing to go in is going to be the first thing to come out when we print our queue here, I want you to be aware of this and really keep your eye out for this, because this is a defining feature of how a queue works. Let's pass this through the compiler. The build is going to be good, so let's clear and run Rooster. We're going to see that the first thing to go in, which is the one thing with 1921, is going to be the first thing to come out when we print our data, and we see 1921 here. This is the first thing to come out. This is working really well. It is also possible to specify the underlying sequence container you want to support your queue interface. This is the syntax we can use to do that. So we can say that we want to use list or deck, and this is going to work now because we modified our print and clear function to take into account that we can pass a second template parameter, which is going to be the underlying sequence container that is going to support our queue interface here. If we pass this through the compiler, the code here is going to compile and run. Let's do this. We're going to use GCC for the job. The build is going to be good, so we can clear and run Rooster, and we're going to see that numbers 3 is going to contain 3 and 4. 3 is going to come out first because it is the first thing to go in, and in numbers 4 we will have 5 and 6. 5 is going to be the first thing to come out because it was the first thing to go in, and this is classic queue behavior. This is all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about the priority queue container adapter. Go ahead and finish up here and meet me there.